Hello, and welcome to another episode of Live with Astronomer. Today, I'm here with Michael Gregory. And Michael, I'll let you introduce yourself.
Thanks, George. Yeah, Michael Gregory. I am a staff engineer at Astronomer, focusing on our ecosystem, building an ecosystem specifically with AI and ML use cases, tools, partners, frameworks based in Amsterdam, where it is getting dark very quickly these days. And glad to be with you today, George.
Amazing. Yes. And so today, the topic of conversation will be Ask Astro AI. So if you're not familiar with what Ask Astro is, you didn't see last week's or 2 weeks ago live. It is an AI that Michael Gregory has built along with some other members of the Astronomer team to basically act as kind of your one-stop shop for, any question related to airflow or Astronomer. So whether you're an Astronomer customer or you're open source airflow user or, using airflow, whatever other way, Ask Astro is a great way to help solve your problems. So I encourage you to check it out today. And if you want to learn more about how to use Ask Astro, check out the previous video. But today the video is going to be more centered around talking with Michael about some of the thought process behind how it was conceptualized, built, what tools did he actually use to create the AI, and just some of the thought process behind, hey, now that we have it, where do we want to take this tool, how to develop it further, and hopefully give you a framework for maybe, if you want to build something similar for your own organization. So without further ado, Michael, I believe you have some presentation materials you'd like to start off with?
Yeah, I was just going to start with a very quick introduction. I know you kind of went through a little bit on the last session, but just in case anybody didn't catch that, Ask Astro is a LLM-powered application on top of all things airflow and Astronomer related, as far as knowledge documents, etc. And just to tee up the conversation, just so if you're not familiar with what it is, you can come in here, you can ask a question, or just click on one that I ran here recently. Ask a question. Obviously, we're using ChatGPT models, and I'll go over more the architecture in a little bit, but to generate responses. In this case, question is, what are the different options for running DBT in Airflow? And so a great way to tap into and leverage all the various documentation out there. I think this is a good point to say, by the way, George, you mentioned that I built this along with the team, but actually in reality, the entire Airflow community kind of built this. Basically, there's so much valuable and powerful documentation, great Slack channels and Stack Overflow. And there's so many sources of valuable information around Apache Airflow, all generated by the community, and being able to leverage those and kind of provide a common kind of interface on top of them in order to build out the framework in order to build out the questions and really capture the knowledge. It's been really useful. We're seeing great uptick on it already. Lots of different customers using it, and internally we're using it quite a bit as well. So that's the quick introduction, George. I guess can go into other kind of structure about how we built it, maybe, or some of those other areas that you would want to ask about.
Yeah. So I think a great way to start, and kind of you alluded to this, is just providing maybe an overview of the conceptual understanding of, hey, why was how Ask Astro was conceptualized, what was your overall plan for it? And then, how did you build it? And kind of just walk us through the beginning of that process before we kind of talk about nitty-gritty.
Yeah, I think the conceptual background is really important because, a lot of our customers, a lot of the community has come to us as a result of our conversations around this with basically the same thing. It's, hey, my company is sitting on a wealth of information for, 100 years of loan documents or whatever that particular industry specific data set. And a lot of companies are sitting on this valuable information and want to leverage it for building new products, for just making their customer user experience better, et cetera. And basically all looking for ways to do this. And they're starting much the same way that we started internally. This project originally started with one of our genius professional services engineers who basically, getting a lot of questions from customers, from prospects, as he's working with customers or working with individual Airflow users. How does this work? What should I look at that? As well as just answering questions in our Slack channels and in Stack Overflow, et cetera. A lot of the same questions come up, and he finds himself often saying, here's the answer, and by the way, here's the document that helps answer your question. He went out and said, I bet we can do this with LLMs. He wrote a very good Slack bot, originally as a Slack bot in our internal Slack channels at Astronomer, that basically indexed and ingested a large portion of Airflow docs, Astronomer docs, etc., with a nice Slack bot kind of interface into asking questions in there. Great kind of first step. And this is, again, where a lot of people start with. They say, it's very easy to build a prototype application, and Llama Index and new frame Haystack. There's lots of frameworks out there where you can build something very quickly and get up and running with a prototype, and it's actually really amazing how powerful these can be with even fairly basic prompt engineering. In this case, we built it based around retrieval augmented generation, which we can go into a little bit if anybody's not familiar with that. But as part of that, as we said, this is actually really powerful, even as a prototype. We took a step back and say, what would it take to go and actually make this more of a production quality thing? Like, what does that look like? Where do we go with it? And how do we build it out? It became very apparent early on that the quality of the data and the quality of the chunking strategy and other things that go into that retrieval augmentation was so important that it actually needed its own kind of structure around it. And so we took a step back and said, if we're going to build this today, retrieval augmented generation, if you're not familiar with it, basically is the process of taking, a corpus of your data, whatever this might be. In this case, it's all publicly available data on an Airflow and Astronomer. But potentially for an organization, this might be, intellectual property, like powerful intellectual property that they're sitting on and they want to monetize for building new products. Taking that unstructured data and building structure around it with vectorization and embedding, putting it in a vector database, and then retrieving data from that vector database as part of your prompt to the ChatGPT or whatever OpenAI or LLM model you're using. And that process, again, it became very, very apparent very early on that basically you could cut the problem space into two big pieces, George, kind of 50-50, like about the time, like the work you do in building out and structuring your vector database for that retrieval process. That's a big part of the work and has to be done well and has to be done right. And then the second part of it really around kind of the front end application, using those vectors, building your prompts, whether you're doing re-ranking, those type of front end pieces as well, another big part of the work as well. And so we built out in the end, what we ended up building was a reference implementation of Andreessen Horowitz's LLM emerging architectures for LLMs. Andreessen Horowitz kind of went through and they looked at the whole space of all the different providers, all the different applications, the building frameworks, LangChain and Llama Index and all the different model providers, etc., and mapped it out on a framework of what all these players were. And obviously, Airflow plays an important part throughout all these pieces. And so when we built Ask Astro, we said, let's go ahead and build a reference architecture, a framework of what it means to pull all this together into, a production quality pipeline that's going to build and build it out. So I don't know if it makes sense, George. Should we go into a little bit of more of the architecture itself, or what's
yeah, definitely. I think telling us, hey, what kind of tools and technology you used, and why they were particularly chosen. You mentioned having vector databases, all these different things to manage. So I think talking about the tools you manage those things would be awesome.
Yeah, so at a very high level, kind of breaking the process up, and I mentioned two, kind of the retrieval and the story, or the storing, ingesting, processing of the unstructured data for the retrieval, then the actual retrieval and the processing, and then feedback loops, and kind of put that into three separate projects. In this case, we're pulling data from GitHub issues, GitHub documents, our own learn and tutorials, and on the Astronomer site. So the Astronomer documentation, which, if you guys are familiar, it's very powerful, like it's a great source of information, not only on Airflow, but also Astronomer capabilities. So pulling all that in, including Stack Overflow, the archives from the Internet Archive Machine, pulling those in, as well as Slack messages from the Airflow Slack channel, pulling all that in, Ingesting it, we're using LangChain for the splitting and chunking process in order to build chunks. If you're not familiar with the chunking process, essentially you have to take large documents and break it into smaller documents in order to fit into the context window of whatever model you're using. In this case, OpenAI GPT 3.5 Turbo, I think it's 16K or 32K context window. So whatever you're feeding into that as a context, obviously you're going to have to chunk your documents. And this becomes a pretty important process, this chunking step. It really, kind of creates the foundation for whether your model is actually going to, whether your application is going to perform well or not. Embedding those chunks, we chose Weaviate for our vector database and getting those all into Weaviate. From there, from the actual application side, when a user asks a question, we'll embed the question and retrieve. Actually, first thing we do is take the original question and ask OpenAI to generate 3 versions of that. And I apologize, George, how much of this was kind of repetition from last week, but a good kind of high level in case anybody missed it.
I was much more high level, so this is great.
Okay, good. Yeah, so they generate 3 kind of slightly different worded versions of that question. Take all 3 of those questions and grab the top K. I think we're using top 10 lately, if I remember right, most recently. Based on a similarity search, simple similarity search at this point, pulling that from OpenAI, and then using GPT-4 to actually formulate the final question, final response that goes back to the user. So that's the kind of the prompt orchestration, a question and answering process. In the application, I don't know if you saw this, but there's also a kind of thumbs up, thumbs down, correct response, good response, bad response, as well as, of course, all the sources for what generated those. So these are the individual documents based on the chunks that were retrieved. And all of that gets collected, and we're using LangChain Smith to kind of collect and suck in all that data from that process. The last piece that we're working on now is the feedback loop, taking all of that context from the question, the answer that came back, the feedback from the user, thumbs up, thumbs down, and then building another process workflow in Airflow that's going to go and take that and move it back through and reprocess and update data in Weaviate and in a structured database that goes with it as well. So that's just kind of a very high level, give an idea for what are the individual pieces in there that were built. Hopefully that wasn't too deep or too high for what you were hoping to see.
No, that was great. And then I think what might be interesting next is maybe you could talk about some of the challenges you face, in managing all these different systems, as you had to deal with such a massive wealth of data and scale. Yeah. I think that'd be cool to talk about as well. Yeah,
that's good. I think a couple of the things that come to mind. So I focused a lot of my work on building this kind of ingest process, taking these unstructured documents, chunking, and building them in. I think certainly what I ran into and what I hear from everybody else, there's not a definitive answer on a good chunking strategy. Obviously, it's different by different types of data that you have. How do you represent that data? How do you break it up into chunks? There's some documentation, some experiences that show too big of chunks also doesn't perform very well. And so finding the right mix of how big your document chunk should be, how much of an overlap, there's really no simple answers on that. The industry is developing, I think, frameworks. Arise has been at the forefront of a lot of it. In fact, they have a session directly after this. I'll do a little plug for Arise. Go check out their LLM evaluation series going on after this. They're doing some great work around some kind of standard frameworks for knowing some of these type of things. But in general, as you're building this out, you're going to have to probably try multiple different chunking strategies. You're going to have to try different embedding models. Maybe you find that GPT is too expensive. You want to try other ones. Cohere's got some great models, obviously, as well. And being able to try different things in there. And so I think from a development standpoint, not painting yourself into a corner where you can build something, try a chunking strategy, try an embedding model, try different schemas in your vector database. And if that doesn't work, kind of start over and try it again. And don't be afraid to do that. And because there's really not a kind of definitive way to do this. And this is where I think some of the benefits of Airflow can really shine as well.
Yeah, maybe you could talk about some of those benefits as well. That'd be cool.
Well, yeah, so the ones that saved my bacon, there's a couple of them. So yeah, honestly, just being able to rerun and retry DAGs. So you run a DAG through, You can build out, the framework that ingests your data, and then say, oh, that sucked, and then just push, wipe your schema out and push the play button on your DAG again with a slightly different set of chunking strategy or overlap numbers, etc. Working on right now kind of a framework that'll do somewhat like a grid search, parameter search, and hyperparameter optimization, where you can try kind of a list of different chunk sizes and overlap sizes, and then do a grid search across those with different ingest into your vector database. If your data sizes are too big, obviously this gets very expensive to try embedding, your same corpus of data 50 times with different chunking sizes, etc. And so I think one of the things that I learned early on was to separate this work also into different pieces. I think this is the Astro instance actually is running nightly and ingesting and running. This is on our the dev system. There's another parallel one in this Astro deployment for prod. But basically there's a set of different DAGs from a best practices kind of perspective. I think this works well. In the bulk ingest DAG, George, I had basically all of the different data sets as like a small subset of the data. So I pulled it from the original source, whether GitHub or Stack Overflow, etc., processed that, and then saved it into a Parquet file locally. Just, the top 50, maybe 100 documents from that. And then I've got it in a local file where I can very quickly read it and reread it and try different chunking strategies. And so this one allows me to take, I got, I think, a dozen or so data sources here, each one of them with 100 or so documents, relatively small corpus of data that I can try different chunks, different overlaps, different models without a massive cost. The embedding models are fairly inexpensive these days. And so I can run this bulk ingest all the way through and kind of start from scratch. If I don't like it, I can delete it, press the run button, and the whole thing goes through. Another important part that was really part of the core development here was the use of dynamic tasks. I'll show a different DAG here for that. It's a little bit easier to read, but sorry, what was that?
No, I just said please. Thank you.
So in addition, so I got this kind of bulk kind of ingest. This is kind of for getting started, getting a basic set of data there, and then breaking it up by source, a different DAG for each source. So Stack Overflow, Slack, our Astronomer registry, GitHub, and then our Astronomer blogs kind of at a high level. And then within each one of those, it's actually very easy to go and add additional sources because we're using dynamic tasks in here. If you're not familiar with dynamic tasks, basically the history of this is originally we were only ingesting, I think, Airflow docs and one other doc source from GitHub, as markdown documents in GitHub. And then inevitably over the course of the project, somebody else would come to me, hey, can you add this one? Can you add this other one? Oh, this is great. This works really wonderful. I also want to do these docs. And so I can just very easily add, basically a list or a data structure of the different data sources that I have. And then the dynamic task will iterate over each one of these and automatically build a flow. So everywhere you see the brackets here, we're using dynamic tasks to map across all those different data sources, which you'll see kind of in the view here. You can see this is 3 different data sources there. So it saved me a lot of time. I don't have to rewrite large portions of code whenever somebody comes to me and said, I also want to add this one. If it's in GitHub, it's in markdown format, I just add another line to my dynamic task generation there. So those are just kind of a couple of things that I think were really important in how Airflow simplifies a lot of this process by being able to just retry individual things. Actually mentioned retry. That's another one I think is very important. Many of these data sources have API tokens, basically API reading, and they'll have API rate limits on them. Almost all of them have API rate limits. And so inevitably, I'm reading from Slack or something like that, and I get some API rate limit exceeded, my task fails. And by simply just setting up a retry mechanism, I think I set it for automatically retry 3 times. All of my workflows go through very quickly because eventually they go through, you see very few failures because they can actually just iterate over that data very quickly. If it fails, hit an API rate limit, retry later, and there's very little hands-on work that I have to do. I can just let that all run in the background. So just a couple of things I thought that were kind of simplified a lot of this workflow for me in building out these tasks.
Yeah, that is super cool. I think, yeah, dynamic tasks and retries, like that's always great about Airflow, just being able to layer those onto literally anything. So yeah, thanks for talking about that. And then I guess one other thing I wanted to talk about. So we really, I think, talked about all the different features of building AI, unless you have anything else you'd like to discuss in kind of that prototype phase. So I wanted to just talk about like a little bit about, when you were going from, hey, working on this in isolation behind closed doors to moving into production, maybe any challenges that arose during that process, maybe any kind of ugly corners it's showing a light on, and then how did you kind of manage those and ensure a smooth shift as you GA'd Ask Astro?
Yeah. This might actually is probably going to sound like a product plug, but it's really not meant to be. So we chose Weaviate as our vector database, and for quite a few reasons. One, because it has a similar kind of open core business model and philosophy that we have at Astronomer. Weaviate's an open source framework. They have a hosted version of it as well. And then the open source version comes with a Dockerized, containerized version of it. And so it actually integrates really well with the Astro CLI. Anybody listening, if you ever use the Astro CLI, just brew install Astro, and you've got a local CLI that allows you to build and create a localized kind of Airflow instance, everything you need to run Airflow locally in just like 2 minutes. You've got a full Airflow instance running locally. And you can also add other containers such as Weaviate. We often end up doing things like MLflow or MinIO or other sources, other things that we need for the development, where it all runs locally on my laptop, and all my vector databases there as well. And so it's really easy to do kind of local development, try again this iterative process of different chunking strategies and different approaches, different models, etc., without running up a lot of cloud costs there. And that was one. And then within Weaviate, two hosted options too. You can build a kind of sandbox, temporary sandbox things, which is great for a staging environment or test or staging. You got your code, it's working pretty well. Now you want to run it in a cloud, in a host environment. And then obviously they're hosted. Weaviate cloud services, their hosted offerings are great, scalable, they're managed, backed up, everything there for our production environment. And so being able to shift between those different vector databases was pretty important. And from an Astro perspective, they actually integrated really well, both with the local CLI for local development. And then when I was going into production, all I did is change a variable at the top of the DAG, which says to use a different API key, Astro deploy, and everything runs now in the hosted Astro environment. So moving from local development into a hosted development environment was really easy. And then same thing once I'm in production, pointed at a different deployment, Astro deploy, with a different key, and now it's talking to the production database. So it really simplifies kind of dev, test, and prod iterative process. You mentioned about rough corners or pain points. I think, actually that was surprisingly easy how much that really worked well together. We are looking at other things like PG Vector, Pinecone, Milvus, and other vector databases as well. And so I think, those will be available as references and templates as well that you can build with. And I think we're going to try as much as possible to build this really simple development process there. I will say, don't expect to get everything right the first time. And so again, be able to and be open to trying lots of different things and set up your test rig in your environment that allows you in a way that allows you to do that.
Awesome. And so you just mentioned, I guess, some other vector databases you want to try, but just more broadly, any more future plans for Ask Astro? Any kind of new features, improvements that you're looking to incorporate in the coming months?
Yeah, good question. I meant to mention this when I was showing this before. Let me bring this up again. Everything we're doing is being done publicly. So everything we build, you'll be able to see it here in this public repo under Astronomer Ask Astro. You can come in here and you can see all of our code. You can see one of my PRs is waiting to be integrated here, but all the DAG code here that I mentioned in the ingest, that's all right here, as well as the feedback loop that's being worked on and built out, and then the actual front end application as well. So all that's here, and you can see in real time. We would love for people to say, try this out, make PRs, make suggestions, give feedback. This is meant to be a community development process. This is not really, Astronomer's intellectual property. Obviously, we're stewards of the Airflow community, and we want to make this tool available just to simply help make Airflow better, make it easier to use for our users and for users around the world. but also this process of building things out. And so we would love to see people come in and say, you know what, I've got my own use case internally where I could just start from this as a template and I don't have to build from scratch. I can come in here and I can change, you know, some of the extract code from different data sources, pointing at different places, maybe use a different vector database that's out there and try different things. And so all that's here. In the short term, some of the things you'll see from us is new integrations with other data vector databases. So I mentioned Pinecone, PG Vector, potentially Milvis and some of the others, as well as direct integrations and new providers and operators with the models themselves, the LLM providers themselves. I think we're targeting Cohere and OpenAI specifically, but obviously this is just meant to be a first integration approach. So everything you see here, if you're like, hey, this is great, but I like Pinecone instead of Weaviate, no problem. You'll see new integrations here coming in the future. One other thing I'll mention too for the future of Ask Astro, our plan is to have it available on the Airflow Slack channel soon. Don't know the exact dates of when it's planned there, but you'll see a Slack bot in here in the Airflow Slack channel that says Ask Astro. You can come in here from anywhere /Ask Astro and you can ask a question. What is the latest version of, what is the first version of Airflow that supports setup and teardown tasks, for instance? Of course, we all know that's version 2.7 because that's right at the top of the mind, but you know, really a wealth of good quality information coming from the bot and right at your fingertips in the Slack channel, where you can also provide feedback and we'll be using that feedback to continually make this AI application better over time.
Incredible, thank you. And then one final question. How does this relate to kind of any other AI or ML projects that you might be working on here at Astronomer?
Yeah, so some of them you'll see in Astro right now. Any Astro users maybe noticed a new button in the Cloud IDE for automatically generating DAG code, and that's a very cool thing that we're going to be doing more on. More work on in the coming months. Lots more with evaluation metrics coming down the road. So right now, you know, being able to understand how things are running, did our ingest and our responses work out really well? And some other ideas that we're talking about and we'd love to work with the community on as well is about things like standardized representations of data. If you're taking, in this case, Ask Astro is a fairly simple and naive process of taking all these data sources. We basically build markdown documents because ChatGPT is pretty smart about dealing with markdown, and it can generate markdown back from the response. And so we kind of standardize on that, but maybe that's not the best thing. There's different data representations out there that might be really powerful in the future, and certainly as models develop in there as well. So if those are of any interest for the community, love to hear from you if your thoughts on those type of topics. And yeah, so I think, you know, I would love to see in the future things like models that predict landing times for tasks in Airflow, and other, you know, these are the type of requests we get quite frequently from the industry. These should be potentially built in directly to Airflow. Over time, I should be able to predict when this DAG is going to be done, for instance. So lots of opportunities there.
Yeah, that is super exciting to think about that. I love seeing AI worm its way into every aspect of our lives.
I detected a hint of sarcasm there, George.
No, it's not. I love AI. It's the best. It makes my job so much easier. So always happy about it. So Michael, I think that is all the time we have for today, but thank you so much for making the time to come on, chat. I think we actually have had some of the best viewing metrics for this of all of our lives. So appreciate that. Guess people found it interesting.
Great.
And for anyone tuning in, come back next week where we'll have an Astro Live on the Astro API.
And there is GitHub discussions, by the way, on the Ask Astro webpage. Great place to bring your questions. Obviously, Slack channels as well, but we'd love to hear from everybody.
Yes, please do. And without further ado, have a good one, Mike.